Hello, everyone. Thank you all for attending. I'm super thrilled to be here. I'm representing Eversource Energy. We're a utility in ISO New England. And we have myself and then two other colleagues here that are also on my team. Together, we make a team of approximately 5 people that use PLEXOS, a rather large company. But thank you, Donnie. He kind of queued up how, as a utility, we actually use PLEXOS in our operations. So who's Eversource? Eversource, we were here last year. I'm not sure if anyone caught us, but we are the largest utility inside of New England. We serve about 60% of all households and commercial operations inside of New England. We own the electric transmission and distribution business. We own a water business, and we also own a natural gas business. We own and operate 4,500 miles of transmission infrastructure, which it's probably not a lot, considering some regions like ERCOT and some of the larger SPP and some other regions. But we also own 60,000 miles of distribution miles. So we are a large company, almost 11,000 strong. But like I said, there's only 5 of us that use PLEXOS and do economic modeling and really transmission strategy in our organization. We have a corporate pledge to hit net zero emissions by 2050. And we try to track our sustainability efforts, and we'll discuss that a little bit in the future. But one thing I want to key up on for Eversource is that we have the natural gas business, we have the electricity business, and sometimes they're a bit competing on some of the public policy initiatives. So the net zero emissions by 2050, burning natural gas obviously is not net zero emissions. So we do have some, I guess, like policies and some strategies to try to mitigate that. And one was we're doing a pilot project for transferring the natural gas infrastructure that is in a town in Massachusetts, so that way it is now geothermal energy. So the residents of the town can use that to heat and cool their homes, and we get to keep the infrastructure in place without having to, completely rip it out and it not be usable. So New England, I know we've only had 1 or 2 people from New England presenting today, but New England is quite a small area, but it's made up of 6 states. They're very diverse. They all have different opinions on how everything should go. Very, very politically motivated sometimes. New England is restructured, so all the utilities inside of New England do not own generation. They are only allowed to own transmission or distribution. We have separate companies for both. Sometimes that makes it very difficult to hit some of the policy targets and some of the, the net zero targets that are set out by these regions. Generation in our region, primarily natural gas. So our region is usually dispatching about 50% natural gas, and that's part of the reason why our prices typically are quite high. We tend to average about $30 to $40 a megawatt hour in energy, and we're typically the second highest in the nation, usually lagging behind either California or Hawaii. We primarily have a high voltage transmission network, but we only have up to 345 kV. I'm not sure if anyone's been to New England. It's very rocky. It's really hard to build anything. There's not a lot of space. So building a lot of this infrastructure is very, very difficult. It's very hard. And you have to spend a lot of money per circuit mile just to get the correct infrastructure in place. But as a lot of people have indicated, AI is a thing, but there's also a lot of policy incentives. Each state in New England has its own target to reduce their emissions. A lot of them are trying to get to net zero by about 2050, which that presents significant challenges as a transmission and distribution company, because to do that, you have to typically turn off all of your thermal resources and try to turn on all of this typically variable energy resources. What's really big recently in New England has been offshore wind. That makes it really difficult because the wind's not always blowing, and if you're building solar, the sun's not always shining. So how do we combat this and try to connect the optimal resources in the correct places? So electrification, which ISO New England projects, so that is electrification of transportation and electrification of heating systems inside of New England. They're projecting it to dramatically increase. Now, every single year for the past 4 or 5 years, they've been lowering the target, and they've been lowering it so that way it accounts for actual registrations of electric vehicles or installations of heating systems in the region. But this is still a main driver of the peak demand that is going to be increasing over the next decade. So I tried to keep the numbers a little bit brief. I know we're all trying to get to a rodeo soon. But this is from their 2025 forecast. They recently just put out a 2026 forecast. And we can see the winter peak transition. So New England is primarily a summer peak system. That is kind of how it's always been. Most people have air conditioning in New England. It gets sometimes hot, not all the time. But this is a new phenomenon. We haven't seen this before. So having a winter peak is very weird for New England, especially if we're trying to get to all of these decarbonization goals. Because if you're building solar or if you're building wind, it's not necessarily most reliable when it's snowing outside. It's very difficult. It's really hard to capture that sun energy. New England, like I said, is primarily fed on natural gas, and that presents another challenge because as a utility, we have to supply our customers, so the residential customers specifically, with natural gas before the generation resources are allowed to connect on the pipeline and get their capacity. So we have a reduced pipeline. Right now the policy is that they're not going to be building any additional pipelines, and our potential generation exceeds our pipeline capacity in the winter. So there are huge shortages and challenges, and a lot of those units have to convert to fuel oil, and when there's large winter events, there's typically scarcity. So if it's a longer, prolonged winter event, they have to get supply of oil and other resources, but it makes it super, super challenging, and this winter was a little brutal. I think the average price was like $80 a megawatt hour. It was just insane. But us at Eversource, we use PLEXOS, just the 5 of us, but we use it in 4 main areas. So early stage transmission development. So we try to proactively identify areas that really need new transmission infrastructure. So whether that be aging infrastructure, whether that be if there's congestion on the lines, which I'm sure you all know about on the PLEXOS models. If we know that there's additional generation projects being interconnected in a different state, then we try to build infrastructure so that way it'll facilitate those connections. Competitive transmission solicitations, so from time to time there will be a need, so whether that be reliability or whether that be public policy, they will request a transmission solicitation, and because we are a restructured environment, we have to compete with other infrastructure developers. So anyone can come into New England and build any piece of transmission if there's a solicitation, as long as you go through all the regulatory hurdles. So we have to actively compete, try to get the lowest price for these types of investments. Project justifications are, I never really liked that term, but my boss loves it. So there's a thing in New England, it's called asset condition projects. So these projects are typically older, so if you see like really old power lines, or potentially there's new conductor materials, the things that they have to change out, and they'll put that through the regulatory process. It'll get approved by state regulators. It goes through this really long process, but we use PLEXOS to justify those investments because we want to make sure that the investments that we're putting on are not just prudent in the fact that they help reliability, but they're also economically good and bad for the ratepayers. And then public policies and corporate sustainability. I mentioned that we have a 2050 net zero pledge. So we use PLEXOS to try to forecast out our corporate emissions and to see how on target we are. So my boss challenged me not to say what the acronym is for this solicitation because I mention it too often. But the New England States Committee on Electricity, otherwise known as NESCOE in our region, put together a public policy-based solicitation. So the goal of this was inside of New England. Maine has a lot of space. There's not a lot of people in Maine. So that means in theory, you can build a lot of generation assets up there. So you have a lot of space. The issue is all the transmission is near Boston, it's near Hartford, it's near Rhode Island. So you need to be able to get any generation that you build in northern New England all the way down to southern New England where all the demand is. So it's very, very difficult. So their main goals were to increase the transfer capability. So they wanted to go from northern New England to southern New England. And then they wanted to facilitate the interconnection of resources. So this solicitation didn't just include building additional 345 kV infrastructure to facilitate the transfer of this new resource, but they also wanted us to build a substation so that way you could connect the resource. So that way, if a new resource wants to interconnect, they already have the interconnection point. They don't have to build it on their own. It doesn't get wrapped up into the cost. So it lowers the bar for those resources. So to achieve this aim, they put out a solicitation. They put it out in March of 2025. It was a 6-month solicitation, which I don't know about any of you, but I don't know anyone that can build a whole new project start to finish in 6 months. And these projects are huge. They take so many man hours. We have 10,700 employees. I think half of the departments in our organization were used in some fashion just to get this project used. So in this, ISO New England did a really interesting new thing. So they required economic evaluation of these transmission projects. So typically, they don't look at economics. It's usually system reliability. So it'd be typically system planning engineers that use PSSE or they use GE Mars, and they do an evaluation to make sure that these projects facilitate, reliability. You can't get blackouts from these projects. So ISO New England decided that they wanted to include a PLEXOS study along with this solicitation. So if you got through the hurdles of making sure that your engineering is sound, making sure that you can interconnect your new project, making sure it did exactly what it needed to do, which is the technical requirements of the solution, if it did all those, they're going to do an economic evaluation to make sure that the benefits that you bring to the region are actually quantifiable. So they measured avoided capacity costs. So we had to do a long-term zonal capacity expansion model. So those resources were floating and fixed bottom offshore wind. They were land-based wind, a lot of photovoltaics, 45 gigawatts of photovoltaics, it's crazy. And then they had energy storage, so they had 8-hour and 4-hour energy storage. And the capacity expansion model would build it where it saw fit, and then we would have to import those results into a longer-term 2054 short-term nodal cost model. So that was a 1-year production cost, 8760 hourly resolution, and we had to bring in those resources into that model and then evaluate the model to see what the benefits were. So the measure metrics, avoided capacity, reduction in production costs, which I'm sure you all are familiar with. Unserved energy, we don't ever have unserved energy in New England. If we did, there's a real big problem. People are using pitchforks and coming after everyone. And then reduction in losses. So typically that's not a metric that a lot of people really care about, but losses on an electric system are resistance. You have to push electrons through wires. The more wires they have to go through, the more resistance, the higher the losses. It adds up over time. So we had a couple really key challenges. So because this has never been done before, us as an organization didn't know how to approach this. It was really, really difficult. I remember before my group members started, I was with one person that now works at Energy Exemplar, and we sat there and ran, 30 different types of models to be I think this is what they're gonna do. Maybe this is how they're gonna evaluate the projects, because it was kind of a black box until they actually issued the RFP. So one key one was, trying to integrate it into our current processes. So I made this fancy little chart, so the top would represent, it's a very high level, holistic representation of a system planning process. So they typically would do steady state, short circuit, and stability analysis. But again, like I mentioned, this is a 6-month solicitation. You can't fit all the engineering and all the due diligence, all the siting, all the permitting. You have to do outreach. You can't fit all of that in, and then right at the end be oh yeah, we'll just slap on some economic analysis. It won't work. So we had to, while the engineers were coming up with their solutions, constantly iterating. We were on 2 times a week, they would be like, oh yeah, scrap that solution, here's another one, scrap that, here's this. It's crazy. But every time that they got past a certain checkpoint, they would hand us the new topology, and then we would just have to run with it and just try to process the solutions as fast as we could, try to get accurate solutions and bring them back. But it was really an iterative process, and it took, I want to say we ran like 100 different simulations on different types of projects. It was quite a lot. Another one was, frequent engineering changes was really difficult to import into a model. I'm sure you all know that they harped on it with the AI integration, which actually sounds really useful now that I had to do it by hand. But the AI integration to make significant changes, significant transmission topology, we had to work with PSSE planning IDEVs, which are not standard. They're kind of difficult to read if you've never seen one before. I know my colleagues are a little bit scared of seeing them, so I have to put them in. But we had to use the PLEXOS API so that way we can automate a lot of these. We didn't want to have to import into 3 separate models all of these engineering changes. We have to build a new substation. We have to increase all these interfaces. We have to change all these line elements, take some lines out, add some in, do that 3 different models. And then, by the way, oh yeah, you have to do it for 10 different solutions at the same time. It just gets tenuous. You can't keep up. So we used PLEXOS and PLEXOS's API so we can automate this process, make it a lot faster, which saved us a whole lot of time. And then the full PLEXOS model runs reserved for project changes. So I didn't think it was too fancy at the time, but apparently it was. I developed a multivariate regression methodology because we did so many simulations. So we got an idea of what are the estimated benefits based on, okay, like we changed these interface limits. What are the estimated benefits resulting from those interface limits? And from that, we were able to say, like, it's generally, we can use a linear regression to say, if you're not changing the interface limits so significantly, we can just skip the run until you're finalized on engineering, and then we can run it from there. And that made a really big impact on communicating results to stakeholders, so that way our leaders could actually make educated decisions on which projects they wanted to move forward with, which ones they didn't. We were making changes until like the last week. It was genuinely crazy. But what did we learn? So as I said, we're a utility. It's not in our wheelhouse to do economic analysis. It is a very new thing to us. I don't know of any other utility in New England, at least, that is doing anything like this. We're really trying to keep up with public policy and match ISO New England on a lot of their processes and try to be a little bit proactive, especially with FERC Order 2023 and 1920. They're all coming out requiring long-term planning forecasts. So we learned that multi-value planning is just the way of the future. We're trying to integrate this process into all of our types of business. We're trying to shoehorn it in to weird parts, like right at the end, just to say, okay, is this a prudent investment? Does this make sense? Because the worst thing would be we make a large investment or we're replacing a line or reconductoring a line and just ends up being, yeah, well, we have increased curtailment. Like we have increased congestion. It's awful. That is a genuine problem that we're trying to overcome and we're trying to incorporate this process in. But also this helps us inform a lot of the policy initiatives. We're proactively talking with state policymakers, Mass DOER, Connecticut, PURA, the PUC at Maine, and we're trying to talk to them to get ideas of where their solicitation's going. They're all buying all these either energy storage, offshore wind, photovoltaics. They're all buying these renewable resources. We need to know where they're going so that way we can interconnect them reliably, efficiently, and economically. So I tried to be relatively quick, so thank you. I hope that we can get to the rodeo relatively soon, and I hope someone gets on the bull.